Hey everyone, Mike Fleming here in the bullpen at Echo 7 Foxtrot Private Investigations, coming to you this afternoon to talk with you about sonar images. We've had a lot of comments and questions pertaining to some sonar images that we released as part of episode 15 of the Secrets True Crime podcast, where we are investigating the disappearance of Susan Osborne and her son Evan Chartrand. As part of that investigation, we went out and conducted some sonar of a former rock quarry, which is now about a 12-acre pond here in Elmore County. We used sonar to map the bottom and to look for any obstructions and basically collect information that would be useful if there needs to be a future investigation there using submersible drone technology or even live divers. So if you haven't heard that episode yet, make sure you go out there, find Secrets True Crime podcast. If you haven't listened to any of the episodes, there's 15 of them out there now. Good opportunity for you to binge and get caught up on that case because we're about to start season 2 of the podcast, which will be an entirely different investigation in another part of Alabama. And that'll be coming out pretty soon. We'll continue to follow and release periodic episodes on Susan and Evan's case. That case is still active, continues to be worked. Got a lot of work still left to be done on that. But definitely, if you haven't listened to it, go out there and get caught up so that this kind of stuff makes a little bit more sense to you and you'll understand why we're doing it. If you aren't familiar with it, you have trouble finding it, you can go on Facebook and look for Secrets True Crime. You can find it using @SecretsCrime. The podcast is available for Apple devices, Android devices. It's out there on iHeartRadio. It's on Pandora. Lots of different ways for you to get to it and listen to it and stay caught up with what we're doing here in Alabama. So the first thing I'm going to do is talk about DownVision sonar. Most of the images that were released after episode 15 came out were actually DownVision images. They created a little bit of confusion. We got some comments and questions about scale of some of the things that we're seeing in the images. Textures, people could see textures in parts of the images. Looked like there might be like some basket weave, something or other laying on one part of the bottom that they didn't see on another, and that kind of thing. So wanted to take a minute and kind of explain how the sonar puts those images together, how it works, to help you understand what you're looking at and be able to interpret some of that stuff. By no means is this going to make you a pro at interpreting sonar. If you're a fisherman and you're looking at or you've recently got your hands on one of the newer CHIRP Sonar systems that uses this kind of technology and can give you high-resolution images, this may actually help you to understand some of that, and maybe you don't consider using sonar cheating when you're fishing, and this will help you out. So we'll go ahead and get right into it. I'm going to pull up a DownVision image. This is actually one of the images that was collected on that investigation. It's not the one that we highlighted in the episode, the one that got everyone so excited. That one's out there. You can see it. I'll talk about it more in depth later on in this video. But for right now, I'm going to use this image as an example to kind of walk you through how the sonar works and how it puts this image together, what it means, and roughly how you can determine the size of some of the objects you see there. So again, this is DownVision. The way DownVision works, the way it's collected, if you're looking at a boat on the water, and I need to make sure that you can see this. If you're looking at a boat on the water, this will be my boat. This is the motor. So we're looking at the boat from the very back. I apologize. If you don't hold this marker just right, it doesn't work. So we're looking at the back of the boat, and the bottom is down here. I want to switch to a different color, hoping you can see it a little bit better. And I think I'll just stick with black. So one of the most important things that we get from the sonar, and one of the things we needed to collect on this particular investigation, was good depth data. So the sonar is mounted on the boat somewhere, depending on where it's best to put it, but it has to be underneath the water, and it is mounted on the boat. So If we assume that the transducer for the sonar was dead center on the bottom of the boat, that would be our transducer. The depth that it reads is going to be a straight line. That's the sonar beam going down. It hits the bottom, bounces back up. The device reads it, and it can figure out just how deep it is. In this particular image, the depth is 38.2 feet. You see that up at the top left-hand side. On the image, where the boat is actually on this side. This leading edge over here, that's the current position of the boat. And if you look at the scale on the side, the bottom is right about here. And on the scale, you can actually approximate and see that it's roughly 38.2 feet there. So over here in the middle, the depth would have been a little bit less because you can see that hump is a little bit taller. It went back deeper and then gets even more shallow on the far left-hand side of the image. All right, the other thing that the sonar does, though, it doesn't just send a single beam straight down. All right, it actually sends out a cone. So what you have is an angle that comes out this way and one this way. One on the left or port side of the boat, one on the right or starboard side of the boat. And so the sonar is actually able to see all of this ground underneath the water. All right, it's able to see all of this at once. And that's actually what you're seeing in this image. The top part, right, where that bright yellow line is, where the image transitions from that red orangish color, that's sediment in the water above the bottom. So where it transitions and you see this solid color, it starts out bright yellow and then it gradually gets darker and becomes more orange towards the bottom. That top part, that is the portion of this image that's directly underneath the boat. If it were a glass bottom boat and you were looking straight down, that's the part that you see. All right, all of this data down here that looks like a pretty picture of the side at the bottom, all of this is the information within this cone on either side. All right, that's confusing because which side is it? And that's the question. The answer to that is that's why some of the people made comments because they saw different textures and stuff like that in that part of the image. The way that image is put together, if this piece of paper is the flat bottom, like I drew up here, the crease that I've got here in the middle, that's actually the part that would be directly underneath the boat. All right? To make this image, what the plotter does is it folds it and shows it to you like this. Okay? So what's directly underneath the boat is just this top leading edge of this folded piece of paper. Everything under that is this side, which is this side of the cone, and this side, which is this side, put together. It's truncated. It merges them. All right, so when you see those differences in texture, looks like a basket weave or something like that, you can actually see some on the far right or far left-hand side of this image. It looks like there's some jagged pieces, but they're not very prominent. It just doesn't look consistent. What that is in this image, on one side, I can't tell you which side because it's DownVision, and that's the drawback to using DownVision. We don't know which side, but in this image, on one side, there's actually some jagged rocks. Those jagged rocks are not on the other side, but when the plotter puts it together to make this image, it merges them, and it makes it look like there's a weird texture over here that you don't see over here, right? Same thing with this tree that you see right about here in the image. It's very clearly a tree laying flat on the bottom, but we don't know what side it's on. It could be this side or this side because DownVision merges those two images. All right, so that's how the sonar puts together those images. And the image in question, the main one that was featured in episode 15 of the podcast, was one of these DownVision images. So the stuff you see in there, it's actually a merged photo, for lack of a better term, of two sides of the boat. So it puts it together not very clear. Now, if you're using one of these systems for fishing, that's fine. With fishing, a lot of times you'll see schools of fish swimming up here in this red portion that I told you. That's the water, right? That's sediment floating in the water and stuff like that. So a lot of times you can see schools of fish swimming in there. Fish also like to hide in ground cover. So if there's scrub on the ground, some grass is growing on the ground underneath the water, fish like to get in there. That's where they lay their eggs. That's where their spawning grounds are. If you're looking for catfish, that's where they hang out. So DownVision can work really well for that because you're looking for the best spot to fish. And if you see it on the sonar screen, you see some scrub brush, maybe somebody tossed their old Christmas tree in the pond and is laying down there on the bottom. You see that on the screen, you know the boat is over that, and fish like to hide out in that. And because of this cone, you don't know what side that Christmas tree is on, but it doesn't really matter. Wherever you cast, you're either going to be in that or you're going to be on the side of it, and hopefully tempt those fish to come out and bite your hook, and you'll be able to catch them. When you're out doing an investigation looking for potential bodies or doing a recovery for someone that drowned or something like that, not very helpful. It can be helpful to help you locate the area, to kind of reduce the area of the pond. Like I said, this was a 12-acre pond. Very good idea to scale that down to a few hundred square feet. But if you were able to clearly see a body on a DownVision image, you still don't know what side of the boat it's on. All right, and you can also tell, because I'm telling you what's directly under the boat is just this line where it transitions from water to solid. All right, just that line is what's directly underneath the boat. So you aren't actually looking straight down on it like if you were in a glass bottom boat. You can't really tell. All you're going to see on DownVision, if the object you're looking for is directly under you, is some change in color here. There's going to be some, it might even go all white. If it's a metallic object, metal reflects sonar very well, tends to show up almost white in these images. So you might see a spot of white on there and know, hey, there was something underneath us right there that I might want to take a look at. So you have to keep that kind of stuff in mind when you're looking at DownVision. All right, another important thing about DownVision that I haven't seen any comments about it yet, but I mentioned to the crew, and it came out in episode 15 of the podcast, that we don't have a scale. We can't really figure out what the size of objects is that we see on these types of sonar images. That's one of the reasons I picked this image to go over, because we clearly have this tree laying on the bottom, all right? And we do have a scale, all right? And I'm telling you there's no scale, and yet you see these numbers and a graph on the side that looks like a scale. And it is a scale. It's a depth scale. It's not a size scale, though. So like I pointed out earlier, the depth finder is reading 38.2 feet here. I told you where the boat is on the far right-hand side of this image. And if you look at that scale, you can see, yeah, it starts at about 38.2 feet, roughly 40 feet. If you try to use that scale to figure out how big that tree is, though, all right, the next mark underneath 40 on this scale on the right-hand side indicates 50 feet. All right, and that's right about at the bottom of the image. 60 feet is way down here. We don't have any data down there. So we've got 50 feet and then 40 feet. The tree, the top of that tree looks like it starts at roughly 40 feet and it runs all the way to the bottom of the data portion of the image. So if you use this depth scale to try and figure out how big that tree is, you're going to come up with an answer of 10 feet. All right? That's absolutely wrong. It is the furthest thing from the truth, and that's what I'm going to kind of explain to you here. So what is that scale telling you? All right, I've already told you, and we'll go back to my drawing here, and just for simplicity's sake, instead of 38.2 feet, we're going to say 40 feet. So 40 feet is our depth. All right, and that's at the center of the boat going straight down. The data over here stops at right around 50 feet. 50 feet is the distance from the transducer on the boat to one of these legs. All right, so that's 50, and this one's 52. That tells us just how far that sonar is. So that tree, if you look at it, it's like the trunk starts up here around 40 feet, And then as you come down close to 50 feet, it makes a little turn, and you can actually see the branches on the tree. The branches on the tree are at 50 feet. So what in reality this image is showing us is that there's a tree on the bottom that's the length of the visible bottom, and those branches, my marker's not cooperating with me, those branches are up here. All right, so here's our tree. And if we use this scale, like I said, we're going to come up with an answer if this thing's 10 feet. We know that it's the length of the visible bottom here, all right? So how do we figure out how big that tree is? We're going to actually have to use some math. And I apologize now if math is not your strong suit, if it scares you, if you don't like it, if you tried to put everything you learned about it in your past. If you're one of those people, welcome to the club, because that's me too. But we know that this is a 90-degree angle. Even if the bottom is not flat, we're going to, for simplicity's sake, we're going to assume that's a 90-degree angle. All right, so we have a right triangle here, and we know the length of two sides of it. That means we can use Pythagorean's theorem to figure out how big this tree is. All right, Pythagorean's theorem is a squared plus b squared equals c squared. All right, c in Pythagorean's theorem is always the hypotenuse. That's the longest side of the triangle, the side that's directly opposite the right angle. All right, so in this case, we know that the hypotenuse is 50. So in the formula, it's going to be 50 squared. We're going to say that b is this unknown side. That's the tree that we're looking for. So we're going to leave that as b for now. A is our true depth. That's the straight down beam of sonar directly under the boat. That's 40 squared. All right. So now we can simplify this formula and actually figure out how big that tree really is. All right, 40 squared, 40 times 40 is 1,600. We don't know anything about b yet, so we'll leave that as b squared. Equals 50 squared. 50 times 50 is 2,500. All right, now we just need to subtract 1,600 from both sides. That's going to leave us b squared equals 2,500 minus 1,600 is 900. All right, now we need to get rid of that square by taking the square root. B is going to be the square root of 900. All right, this is a really simple problem. We know that 30 times 30 is 900, so B is 30. Our tree that we thought was probably 10 feet tall based on the depth scale is actually 30 feet long. Hopefully that makes sense, and you can use that to understand why we don't really have a size scale when we're looking at DownVision images, and why it's difficult to determine just how big the objects we're looking at are. If you have any questions, definitely post them on Facebook. You're welcome to email them to me. Go ahead and ask, and I'll try and explain it, but hopefully this should give you an idea of both how these images are put together for DownVision, how the sonar actually collects that data and represents it on the screen, and a rough way that you can estimate the size of things that you see on the screen. A lot better than trying to use the depth to figure it out, right? Because like you can see here, not very accurate to do it that way. You really need to do some math if you're going to try and estimate how large those objects are. Big difference between a 10-foot tree and a 30-foot tree. All right, everyone. I want to thank you for joining us. Hopefully this was informative, helped you understand some of these sonar images that were released along with episode 15 of Secret's True Crime podcast, and otherwise just gives you a better understanding of looking at CHIRP sonar images. In this particular investigation, we used Raymarines Element sonar, CHIRP sonar system to conduct our operation. Our goals were mainly to map the bottom. We created a a complete cartography of the bottom of that pond, and we were looking at the sonar images mostly to identify any obstructions that might be on the bottom. All of that's covered in episode 15 of the podcast. If you haven't listened to it yet, again, go out there and find it. There's 15 episodes for you to binge on. Get fully caught up on our investigation into the disappearance of Susan Osborne and Evan Chartrand. If this video was helpful for you, you enjoyed it, please be sure to like it, subscribe to the channel. Go out there on Facebook and find @Secrets Crime. Be sure to follow that page. That's where you'll find all of the information about future episodes coming out. We're about to launch season 2, completely new investigation in a different part of Alabama. Very exciting. Think you're going to really enjoy that. So be sure to go out there and follow the Secrets True Crime Podcast Facebook site. You can also check out Echo 7 Foxtrot on Facebook. Our short tag is @Echo7, the number 7 Foxtrot, and hope to find you there. If you have any questions, feel free to reach out to us, and we'll get right back to you. Again, thank you for joining us, and this is Echo 7 Foxtrot out.